You know that old saying about how every time a bell rings, an angel gets its wings? Well, just like that, when a YouTube channel gets to about 250,000 subscribers, it gets a Storinator. But what the heck's a Storinator? Why do I need one, and how do they set up? Well, those are just a few of the things you'll learn in the next few minutes. Hey, I'm Dave. Welcome to my shop. I'm Dave Plummer, a retired operating systems engineer from Microsoft, going back to the MS-DOS and Windows 95 days. And today, I'm deploying a machine that I don't think I could have imagined back in those days, the Storinator from 45 drives. Now, mine will have only 30 drives, but at 14 terabytes each, that still comes out to a raw 420 terabytes. I mean, it's not Linus Tech Tips, but then again, I don't have their LTT fat water bottle budget, so you have to economize somewhere. Now, the need for all of this comes about as a result of squirreling away the source videos for everything I make here on the channel. Now, if I just kept a 4K render of the final videos, I'd be okay, but the Final Cut project that produces that 4K video can be anywhere up to about a half a terabyte. Make one a week and it starts to add up to serious space pretty quickly. I've become slightly more efficient about the way I store the original source material and so on, but there's no avoiding the reality that Final Cut projects take up a lot of space. First, we'll look at the machine itself, and then I'll mount it in my equipment room here in the shop. It's a bit too deep for my home rack, and it's a bit too loud to sit close to me here while I'm recording. And I figured the best place for it was the equipment closet where I have my air compressor now. I built it with sound insulation in the walls to dampen the sounds of the compressor, and it should do a good job of silencing the server as well. It's already reasonably quiet, as it's the Q30 model with Q standing for quiet. As for other specs, it features a Supermicro XP11 SPL motherboard, a Xeon Silver 4216 CPU with 16 cores and 32 threads, 120 GB of ECC error correcting memory, dual 10 GB network cards, two 16-channel host bus adapters with battery backups, an IPMI remote management interface, and much, much more. Now that the server is up and running, I want to confirm that it fits and that it works in the server closet before I invest too much time testing custom configurations for it. Once I know that it all works in place, I can throw it back on the bench to fix it if needed, but I should never have to. Thanks to the IPMI interface, I should be able to connect to the motherboard over the network, even when the system is shut down and powered off. How's that possible? It's all thanks to IPMI. IPMI stands for Intelligent Platform Management Interface, and long story short, it allows you to connect to a chip that lives on the motherboard, and that chip stays on even when the main board is technically powered down. Among other things, that chip is able to connect, start, stop, shut down, and reboot a machine through the web browser at any time, as long as there's a connection to the network and a special IPMI management jack being used. It's a special third jack provided on the back of the machine used just for this purpose. When that port is plugged into the network, it gets a DHCP address that you can then connect to with your web browser. You can see the contents of the screen and control the server entirely remotely. This is why I'm able to mount the machine off in a closet and still interact with it, even tweaking and upgrading the BIOS as needed, just as if it were sitting next to me. Let's get the machine mounted in the closet, and then we'll see if Windows can even handle 16 drives at once. Let's take a quick tour of the Dave's Garage Storinator. This model is the Q30, built by 45 Drives Corporation. And this model, of course, features room for 30 drives, so it's less deep than their 45 and 60 drive units. Features a Xeon 4216 Silver processor under a force-fed heatsink, as well as two host bus adapters, which are also under a force-fed fan to keep their heatsinks nice and cool. That fan, however, is in the way if you want to install an NVMe stick here on the motherboard, which I plan to. I want to add a Optane stick, which means I'll have to move this plastic adapter to the far away peg, which means removing the host bus adapter temporarily. So let's do that and install the drive. With the drive installed, you can see that I've moved the peg to the far side. It's kind of a nice little feature, avoids having to fuss with a screw down in that point. The whole case design is really well thought out. As you can see, there are notches here for your screwdriver to pass through if you need to get back at the card slot screws. The host bus adapters each feature a battery pack, which will, in the event of a power outage, keep the stuff that was in RAM on the cards in RAM, and that way it'll be able to be written when the drives come back up. There are actually two ports on the back of the machine that are important. One is a 10 gigabit port, and there's actually two of those. Then there are two 1 gigabit ports and one 1 gigabit management port. The yellow cable is the management port, and as you'll see later, it allows me to even control power on and view the machine remotely even when it's not turned on. The green cable here is going into one of the two 10 gig ports, and that leaves two 1 gig ports open on the main board. Here's a quick look at the backplane where the drives slot into. As you can see, it features a SATA connector along with power for each of the drives, so there's no wiring. And time for the obligatory sped up Dave's installing a lot of drives shot. Now there's going to be 30 drives eventually, but I'm going to start with 16 here because that's what I have fresh. Once I'm certain that everything is working properly and being properly backed up, I can bring down one of the other 3 NASs and move its drives over into this one, consolidating them all into about 420 terabytes of space in the single unit. My plan was to start with Windows, and so that's how I spec'd the machine, and that's how it arrived conveniently set up for me. All the host bus adapter and RAID configuration was already done. This is the closet where I plan to hang the server on a 4U rack which mounts to the wall. To mount it to the wall, I'll first locate a stud, and then using the laser level, which protrudes out at a perfect level, which is very handy, I will go over and mark the next stud. One design feature that I really like about this stud finder and laser level is that once you've located the stud, you can simply use your pencil or pen to mark through the very center of the device, and that will put it right on the stud. No more having to back off and figure out where the middle was. I'm going to run a 3-inch lag screw through each of the mounting holes with a washer to secure it deep into the stud, wishing only that it was a Torx or a Robertson drive. Unfortunately, it's Phillips, which makes them kind of easy to strip when you're going into a hole this deep without having pre-drilled it. This is going to be an incredibly level server because I'm going to check it again with a bubble level here before I actually tighten down any of the hardware. But once I can see that it is in fact level, I zoom it down and we should be good. The empty server itself is 65 pounds, and the drives probably add enough to bring it up over 100, so you want to make sure that you've got your rack securely mounted and that it is in fact rated to take that kind of weight. I'm adding the cage nuts for the retainer hardware because even though it's not being mounted horizontally, I still don't want it sliding off of the actual rack. And with the rack in place, it's time to go grab the server, and we can just mount it by sliding it in. Once it's in place, we simply tighten down some of the retaining hardware, and we'll soon be ready to load drives. With this setup, the server never actually touches the wall, it's completely suspended, hanging in the rack. And now I can reload the drives back in because I took them out to save the weight while I was loading and mounting it. And as you can see, I'm very good at it now by how fast I'm going. I've got a temporary UPS and a switch there while I await the better units, the permanent ones. Terminating fiber optic is hard and expensive, so I'll just leave the extra there coiled up behind the UPS. With the server mounted and connected to the LAN, it was time to start experimenting. The first thing I wanted to try was Windows' native storage spaces system to see how well it could cope with 30 drives. Now technically I didn't need 30, and in fact I hit a wall, as you will see, with only 16 installed, and it could have been far fewer. Now I should stress that normally, 45 drives would ship the machine with Linux and topped off by the proprietary Houston UI. The Houston Control Center would definitely do everything that I'm likely to ever need in terms of setting up my NAS, but being an old Microsoft guy, I really want to let Windows swing for the fences with some large arrays. And Houston isn't intended for Windows, but when I insisted that my new server be set up with Windows, they cautiously agreed. Suffice to say, however, that any pain I experience in doing these things the hard way is completely self-inflicted, because 45 drives normally ships a machine with a simple and elegant open source way of managing your NAS out of the box. But what fun would it be if I took the easy way today? So when 45 drives ships this machine with Windows, it's configured as hardware RAID, and it's set up using the Mega RAID controllers and software. I was going a little off the beaten path here because I was going to allow Windows itself to manage each and every one of the drives, rather than letting the hardware RAID controllers do it. But that meant I had to get the controllers to pass the drives all along to Windows directly, rather than aggregating them into RAID volumes as they were doing beforehand. From what I was able to find on the internet, it appears the solution is to reflash the host bus adapter's firmware with what's known as the IT version of the card's code. But I wasn't really in the mood for flashing storage controllers, and I didn't want to deviate the machine too far away from how 45 drives had initially configured it. The last thing I wanted to do was to have to call the support and tell them, I don't know, I reflashed the hardware RAID controllers with unapproved firmware and now it's not working right anymore. There had to be a better way, and there was, through a card BIOS setting called JBOD mode, but it took me a long time to find it. Now there are two versions of Windows software RAID. There's the old school way that I used back in the late 90s on NT, which is through the disk manager, and it can create stripes and mirrors and RAID 5 sets. But I'm told by those who should know, however, that it's now deprecated and it has old known bugs that are not being fixed anymore in favor of work being done on the new Storage Spaces RAID code. Storage Spaces is Windows' more modern solution to RAID, and it allows you to create storage pools for multiple drives and then to build RAID arrays on top of those pools. Now, I'm not expecting ZFS for Windows or anything fancy, but I presume it's more advanced than the old stuff if nothing else. I'll try both and show you how quickly it's done on each. First, I wanted to create a RAID stripe set, the fastest and most dangerous kind, of 16 drives and see what the performance was going to be like. With a stripe set, when the data is written out to the drives, 1/16 goes to the first drive, 1/16 goes to the second drive, and so on. When it's time to read all that data back in, it can read all 16 at once, and hence a large stripe set of conventional disks can approach SSD transfer rates, as long as the heads never have to move. After we try the stripe set in the old management interface, I'll create a fault-tolerant pool in the new storage spaces, and of course, I'll then test both with Crystal Diskmark to gauge the actual performance. Let's have a look. To get my drives to show up at all in the device manager, I had to set the controllers to JBOD mode, which is just a bunch of disks, which is to say, not RAID. Now, whether I wind up with Windows Software RAID or with ZFS, it's going to be in either case a non-hardware RAID solution, so I need the drives exposed. And now that I've confirmed the drives are ready, we can go into Create and Format Disk Partitions. This is the old school, old software, deprecated, not supported anymore, probably shouldn't be using it, but I want to see if it works, so let's try it. Let's go in and see if I can create a massive drive stripe array. Now, the problem is these drives, having already been formatted and partitioned by probably the hardware RAID controller, already have partitions on them, which I now have to delete. And there's no multi-select, can't do this in DiskPart, so I've sped it up because it was painful and took a long time to go through and one by one delete every one of these partitions. And with all the drives now empty, I can create a new striped volume. I'll say next, and I'll add all but one drive here because I'm keeping one as a spare in most cases. That will give me 15 drives in the array. Let me confirm that. 0 through 14, correct. Give it a drive letter, and we'll get it going in formatting. When it was done, I was a little surprised to see the volume also reported as the same size as the disk. That would be true if you mirrored it, but it should not be the case for a stripe set. So I brought up command prompt, went in, did a quick dir. Let's try that again. And dir, you can see, yeah, there's 210 terabytes here, so that looks better. And with the enormous stripe set created, let's go in and try a Crystal Diskmark to see how it works when it reads and writes from all the disks at once. And because they do about 200 megabytes per second on their own, these numbers actually look pretty respectable, except for some of the random reads, which are kinda pathetic. Either way, it's more than enough to saturate a 10 gig network link, especially when you consider that that is 3.5 times the throughput of the network. Of course, this would be an incredibly terrible idea, because if any one of the drives experienced a problem, all of your data would be gone immediately. And so what we want is a fault-tolerant set, and we'll do that using storage spaces. We could create a RAID set using the old system, but this new one, the managed storage spaces, is the currently supported and developed and updated one, so I'm going to assume that it's safer. I have no proof of that, but we'll find out. I will unselect the Optane that I threw in there, it will prepare the drives, and then we'll create a storage pool out of them all. No, we won't. And we didn't for about a day, which I will spare you. So the problem turns out to be that you have to go in and disable each of the disks and then re-enable them, or physically disconnect and reconnect them if they've been part of another RAID system. And yeah, it took me a while to figure this out, so I have to go through and disable each of these drives because, again, no multi-select. Maybe there's a PowerShell way to do this, I really don't know. Either way, I then re-enable each of the drives, and I then should be able to create a new pool in storage spaces. I'll make sure all the proper drives are selected, and I'll click Add Drives. It'll churn away, say preparing drives here for a while. It'll then add the drives to the pool, and when we're done, we should have a 200 and some terabyte pool, which we do. And so at this stage, we just have a pool of physical drives. There's no volume, there's no partition, so we have to create a storage space on top of the pool in order to do that. I'm going to select the parity option, which I believe to be roughly equivalent to RAID 5, as it protects you from the failure of a single drive within the set. If I do that, it leaves me with 135 terabytes of my 202 terabytes free. Sadly, it just kept saying the amount was not valid until I tinkered around long enough to figure out that the limit is apparently 63 terabytes. That's right, 63 terabytes. That's all you're allowed, no more. Kind of weird. At this point, I was really only now concerned with testing the performance of the pool, so I thought, what the heck, I'll create the 63 terabyte, we'll run Crystal Disk Mark on it, and we'll see how it does. So, with the storage space now created, we'll launch Crystal Disk Mark and see how it does. 532. Now with this many drives and a good CPU, I'm surprised the read speed's not faster. The write speed may be constrained by how fast it can write to any particular drive, but I was hoping for more on the read side. This is not really a fault of the system in any way, it's just Windows is probably not intended to fulfill this role. I was surprised to see that Windows is held back in this case by its limitation of 63 terabytes on a single storage space. Because you can hit that today with as little as 4 drives these days, so it's not like some theoretical edge case that I happen to hit. With Windows ruled out of contention for today, my next experiment would be to install Proxmox on the machine as a hypervisor, and then install TrueNAS Scale as a storage solution. It's worth taking a moment then to explain what these pieces do and why I selected them. Proxmox is a virtualization environment. That means when you install Windows or Linux or perhaps both side by side, the operating system does not run directly on the hardware. Instead, it runs on Proxmox, which looks like the hardware, and then Proxmox in turn runs actually on the hardware. Windows thinks it's talking directly to the hardware, but it's really talking to Proxmox, which arbitrates access to the hardware from perhaps several operating systems running side by side on the same machine at the same time. This is possible because of that virtualization layer inserted between the virtual machine and the real hardware. That layer is part of a piece of software typically known as a hypervisor. More important, however, is the fact that multiple copies of an operating system can be run on the hypervisor at once, and you can even mix and match operating systems at the same time as well. In fact, now that nested virtualization is supported, you can virtualize your virtualization environment and pretty soon it'll be turtles all the way down. But why would we even want the complication? Well, with modern servers being as powerful as they are now, it makes sense to effectively timeshare their resources just like they did for mainframes in the old days. You can run several Windows and Linux virtual machines on the same hardware at once, and the hypervisor manages the whole thing so that each one thinks it's the only system in town. Plus, problems, if any, are compartmentalized to the virtual machine that they're running on. You can reboot one VM without touching the rest of the VMs. Proxmox and the Windows hypervisor are both Type 1 hypervisors, which mean they run directly on the hardware and then present virtualized machines to the operating systems that are installed atop them. Contrast this with something like VMware or Virtual PC in the olden days, which were installed on top of Windows, not below it. Without the cooperation of code way down in ring 0, a virtual environment must simulate or emulate many of the resources. All that aside, in my case, I'm adding the complication of virtualizing the server so that I can run Windows, TrueNAS, and Ubuntu all at the same time on the same machine. By now, you might be thinking this is a powerful concept, but at what cost? How much slower is it than running those same operating systems on their own dedicated hardware? The answer turns out to be 1 to 3%. And it's really hard to think of many problem spaces that could not afford to trade that trivial level of performance drop for the flexibility of virtualizing the hardware. Now, 45 drives ships the system in a fault-tolerant mode with two 500GB drives mirrored to form the boot drive. Not wanting to change that for my experimentation, I considered first an SSD on a USB stick, and then ultimately this PCI-based OCZ Revo drive, which is quite small at only 250GB, but it's been solid reliable for 10 years, so it should serve me well for today's tests. And once it's installed, the card will also be handily cooled by this overhead fan, which is actually intended for the host bus adapters, but which will get some airflow going to the SSD card as well. And with the PCI SSD installed, I can now use it to install Proxmox. It's actually my first time ever using Proxmox. I don't know that much about it. I've used Hyper-V under Windows, so I'm kind of a noob, but I get the idea. We'll try it right now. My rationale for picking Proxmox over, let's say, Windows Hyper-V in this case, is that I wanted to be able to pass my host bus adapter cards easily through to the underlying operating system in the VM. That seemed to be quite a bit of work if you were going to try it in Windows, then it was as easy as a drop down in Proxmox, and so here we are. The one other consideration is to use the virtual I/O network drivers. I believe that instead of emulating an Ethernet card, it actually allows it to pass data with the operating system and the hypervisor working together, and it's significantly faster. So that's what I'm doing as well. In fact, when I spoke to Jeff at Craft Computing, he assured me that I would likely not need to pass down a 10 gigabit network adapter to TrueNAS itself. He said that the performance on the virtualized adapter was good enough, and in my testing I was able to easily saturate a 10 gigabit connection with iPerf, so it seems to be true. And speaking of TrueNAS, I'll run you very quickly through the steps of creating a storage pool, adding a data set, and sharing it out to the LAN. I'll breeze through this pretty quickly, not so that you can remember how to do it from having watched me, but to get that level of dilettante knowledge that I personally value a great deal. Knowing that something is possible, even if you then have to look up the actual steps later, should you need to then do it yourself. Now, the first thing we're going to do is to log in as root. We'll get to the system dashboard here, and we'll go click on Storage, where we can create a new storage pool. We'll click Create Pool, and now I have the option of passing through whichever of my disks that I want to use as part of the pool. When I select all, it does in fact select the other pages, which is handy. And so I'm going to check all but one because I'm going to keep a hot spare for later. And so 14 storage drives, one hot spare, and we give it a title, Main Pool. Told you I was going to go fast on this one. You're going to get your money's worth, trust me. When we do, it will run off and it will create the pool. It will add the drives to it, do all the steps necessary, and then return to us a pool of drives upon which we can create a volume or a data set. We'll create a data set called main data. And now we want to share that data out on the network in a way that our clients can consume. SMB is going to be our best bet here in this case because that'll support Windows and Mac. And of course, Linux with optional packages has the ability to handle most SMB cases as well. Then as soon as I click share, I'm offered the opportunity to enable the service automatically, which I do. That simply means that SMB sharing will be turned on every time the system boots. Now I'm going to add myself as a local user here by entering my name, a username for myself. I don't want Plumber, I want Dave, and my email address. Don't hassle me, man. And then my password, and I will confirm my password. And then we'll jump ahead a second here, and I'm just going to copy a file and see how well it works. This is presently copying from my local RAID array up to the network, and it seems to run at about 1 gigabyte. And the transfer rate being reported by Windows matches what I see in the network box according to TrueNAS, so it seems to be transferring at very close to 1 gigabyte a second. Not bad. That was ultimately my goal. A large NAS setup that could easily and reliably saturate a 10 gigabit networking connection in both directions. It's got dual power supplies and dual path networking, and I can edit 4K video projects off it completely live with great scrubbing action, and that's really all that I need to call it a success. I'd like to send a big thanks to 45 Drives for supplying the hardware needed to evaluate these scenarios today, and to remind you to make sure that you're subscribed to the channel if you want to see more episodes like this one. Thanks a lot for joining me out here in the shop today. I really enjoy making the occasional video on these somewhat niche tech matters that you might not otherwise encounter, so if you enjoyed it, please leave a like and consider subscribing to the channel. Both help a great deal with the algorithm. If you have any interest in matters related to autism, Asperger's, or ASD, please check out my book on Amazon, Secrets of the Autistic Millionaire. It's got nothing to do with money and everything to do with living a successful life on the spectrum. It's everything I know now that I wish I'd known back then. Remember, I'm mostly in this for the subs and likes and to be able to raise enough money to fix my screwed up LEDs behind me that keep changing color, so please be sure to leave me one of each before you go today. In the meantime and in between time, I hope to see you next time, right here, in Dave's Garage. I can throw it back on the bench. With Windows ruled out of contention for today, my next two 16-channel host bus adapters with battery backups, an IPMI remote intervention, blah, 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 blah. Dink. All right. And to remind you to make sure that you're subscribed to the channel if you want to see more important episodes like this one. Important? The hell's important about it?